right, today I'm going to show you guys how to write compounds and formulas for molecular compounds, also called covalent compounds. And those are compounds. So remember that if you have a metal, those things over here, with a nonmetal, it's an ionic compound. Also, metals with polyatomics are ionic compounds. But what we're looking at today is this combination here of nonmetals. When they combine with each other, metals want to get rid of electrons, nonmetals want to take them, and that's how they go together. NaCl. Sodium loses one electron, chlorine gains one. They're happy that way. You know, one's got a plus one charge, one's got a negative one charge. The total charge of that compound is 0. And so the only way that compound can go together is NaCl. But what happens with nonmetals, they can combine with each other, but one doesn't give electrons to the other. You cannot use their charges to determine how they go together because they're sharing electrons, and they can share 1, 2, or 3 pairs of electrons. And so what happens when nonmetals combine with each other, you can have many different compounds associated with them, and that's not the case when you're talking about metals and nonmetals. For instance, you can have the compound CO, the compound CO2, CO3. Those are all possibilities. So because of the fact that they share electrons and they can share different numbers of electrons, we have to indicate in the name how many of each atom are actually there. If we did not, every single one of these, if we use just the ionic naming rules, metal and nonmetal, that would be carbon oxide, that would be carbon oxide, and that would be carbon oxide, and they're completely different. So we have to account for that. Now here's what we use to name molecular compounds. We use prefixes to indicate how many of each element are there. Again, another bright spot for this year about memorization is in the past we would always have our students remember all of the prefixes associated with this. But again, because some of you are at home and all of you are using your notes, we're not requiring you to know those. So again, that makes things a little easier when you're doing this stuff because you don't have to remember what tetra means. So it says write down the symbol for each atom for this particular compound. Notice diphosphorus pentoxide. You start seeing these prefixes when it is a combination of two nonmetals. And again, I want to emphasize that, the nonmetals. So there is phosphorus, there's oxygen. Because some people are like, when do I use these prefixes, when do I not? And I've also seen people in class over the years that I teach this on the last day and suddenly they want to use prefixes for everything. But this is for only combinations of two nonmetals, the elements that are over here. So there's phosphorus, there's oxygen, diphosphorus, P2, di means 2, pentoxide, there's no crossing of charges. There you go. There's the compound between phosphorus and oxygen. Don't look up the charges for two nonmetals because they're not relevant. More practice. Nitrogen trifluoride. So again, there's nitrogen, there's fluorine, so it's two nonmetals, NF3, all you have to do. Disulfur dichloride, there's sulfur, there's chlorine, S2Cl2. You do not have to simplify molecular compounds. They can actually exist as multiples of each other, and they have different characteristics. So a compound like this and a compound like this as molecular compounds can exist, and they don't necessarily have the same properties. So the next one, again, dinitrogen, we just did that, tetraoxide, N2O4. So there you go. So don't reduce molecular compounds again. They exist as multiples of each other, what I'm pointing out again. Carbon tetrabromide, carbon, again, there's carbon. It is a nonmetal. Bromine's over here, and so tetra means 4, so 1 carbon, 4 bromines. Diphosphorus trioxide. Now, when there's only one of the first element, go back up here, you don't have to put mono in front of it. But if there's one of the second element, I want to just point this out, then you need to use mono in the name. So that would be dicarbon monoxide, because there's one of the second element. So you might be asking, why haven't we used mono for this? So when it's the first element and there's only one, you don't have to use that. All right, naming molecular, you can do those practice on your own. If I were you, like I said, I would pause this, go do the practice. Again, when you're naming molecular compounds, you have to use prefixes to indicate how many of each element are there. First thing you do, so we know it's molecular because, again, it's a nitrogen and oxygen there, two nonmetals. And so nitrogen and oxygen, drop the ending like always and change it to IDE. So you drop the last syllable or sometimes the last two and change it to IDE, nitrogen oxide. But then you also need to use prefixes to indicate how many of each element are there. So that is nitrogen dioxide. There's only one nitrogen in the front, so we don't have to say mono nitrogen dioxide. It is understood. Remember, use mono when you have one of the second element. So again, when we're naming these, if you have to, like I say, when you're naming compounds, you always have to look at the periodic table to name them. Because if you don't, you're going to miss 2/3 of them. Because nitrogen is here, and when the first element is a nonmetal, then again, you need prefixes in the name. So that would be dinitrogen, because there's two of them. And remember, there's only one of the second element, so that's what you have to put so monoxide. That means there's two nitrogens, one oxygen, PCl3. So again, so that is phosphorus. So phosphorus trichloride. Again, we got to use the prefixes because phosphorus is right here, and again, it's two nonmetals. SF6. There's sulfur. There's fluorine. Sulfur. Hexa. Fluoride. OF2, again, two nonmetals. There's O and there's F, so oxygen difluoride. And then Cl2O7, again, two nonmetals. There's chlorine, Cl2O7. So that is dichlorine heptoxide. And then the next one, and this is a very commonly missed problem. So let me show you a common mistake for this SO3, and I'll put a big X through it so you'll know how to do that. Because I can't tell you how many people over the years would go, you know, what's the name of SO3? And they'll go, sulfite. Okay, that is not correct because it does not have a charge. SO3 with a -2 charge, there it is sulfite. But the 2 extra electrons gives it different properties, so it has a different name. So this is just SO3 without a charge. You might say they didn't put a charge there, so that's why you assume it is just a molecular compound between sulfur and oxygen. So that is sulfur trioxide. All right, do the rest of those on your own. Again, you can come back after you've done that. And I do want to show you one more thing there with more practice. And remember what I've been saying. I said that if you don't look at the periodic table when you name compounds, you will miss 2/3 of them because they look almost identical. And so you might want to say, okay, if you're not going to look at the table, you go calcium chloride, copper chloride, and carbon chloride. If you did that, you would miss the last two. So, because here's what you always have to do. When you're naming compounds, if the first element is a metal that you know the charge of, that would be group A. So the metals that we know the charge of, again, column 1, column 2, aluminum, zinc, silver, and cadmium. If it's one of those, we can simply name it, and then that's it, and drop the ending in that ID, again, if it's a binary compound. In other words, there's no polyatomic there. So there's calcium. There's calcium. We know it's charged, so we don't need to add a prefix. We don't need a Roman numeral because it's always 2, so it's just calcium chloride. And if you go, why don't we put dichloride? That is the only way that compound can go together. Calcium has got, again, 2 valence electrons. The dots indicate valence electrons. Here comes the chlorine. I'm going to put 7 dots to indicate it's 7 valence electrons. Calcium gives up 1 electron to a chlorine, but here comes another one because calcium still has an extra electron. It can't give it to that chlorine because it already had 7 valence electrons. Here comes another one, and there you go. Goes together like that. Now calcium's +2. The total charge of that compound, again, is 0. That's why crossing the charges always allows you to put the formula together properly because it's just keeping track of electron movement. Chlorine being -1 means they gained electrons, and calcium being +2 means that the calcium lost 2, 1 to each chlorine. And so that's the only way that compound can go together. We don't need to call it any other way, because when you're talking about groups of non-metals like this, they can go together many different ways. So we need to account for that and then use a prefix to name that compound. All right, the next one, copper chloride. There's copper right there. We don't know its charge. Metals are always giving electrons to non-metals. So since we cross the charges to put that together, you have to uncross them to figure out the charge of copper. So again, the way we do that is that we always check the charge of the non-metal. And then you ask why again? It's because we always know the charges of the non-metals, because they're -3, -2, -1. So there's chlorine, got a -1 charge. So it's 1. Notice they didn't bring the 1 down there, so that means it has not been simplified. That means the 2, again, came from copper. And so that would be copper, Roman numeral 2, chloride. And then the last one, there is carbon. 2 nonmetals. Got to use prefixes in the name. So that is carbon dichloride. And then there's some really good mixed practice there where each case, to name it, you're going to have to consider where the first element is. And just so you know when you're getting started, if you're using the same method for those first 3, you're going to miss 2 of them. Because again, one's transition metal, one's a metal you know the charge of, and then one of the first elements is a non-metal. So good luck with this.